all, let me introduce myself. Cesar de la Torre. I work as a principal program manager in the Azure Machine Learning product group. And most of my time is focusing on AutoML, but also other training areas within Azure ML, right? So the agenda for today, it's to I will give a brief intro to AutoML, because maybe in the audience some folks might not be familiar with it, and then I will drill down into this particular feature that we have in private preview, which is AutoML model training code generation. What is the feature, how it works, and also a way to enroll to the private preview and get started with it, right? So this is basically the agenda. So, giving us the back.
Sounds very cool. We're gonna fade out, Cesar, and then we're gonna regroup at the end, and then we can have a conversation about it and maybe have some Q&A.
Cool. So within Azure Machine Learning Service, kind of our goal as a platform and product is to help on productivity and help on the quality of the models, and this is a very important area, how to productionalize your models and to deploy, how to manage, right? That's part of MLOps. However, in this session, we're focusing on a particular area in Azure, which is automated machine learning, right? And it's a way to have a lot more productivity when creating models, when creating machine learning models. So from a perspective, when you are creating a model, there's a lot of work preparing the data, then building and training models, changing how you work with the data, the input data, and the model's parameters, hyperparameters, and then deploy, right? But that iteration takes a lot of time. So I will be doing a few demos related to a particular example, which is a model for predict if a driver or not. That was a Kaggle competition some time ago, but I will be focusing on this particular example, right? In the model that I will be showing how to do it. So the model manual, like if you are just using any framework, scikit-learn or other library like IGBM or any library, at the end you need to, if you do it manually, you need a lot of time iterating, like I was saying, right? You need to select what features or what columns of data you're going to use from the data set, because you initially might not know what data impacts on the predictions and what other data might be relevant for the model, right? Then you need to select what algorithm are you going to use. I could choose gradient boosted or IGBM, but how would you initially, which one is going to work better for a particular machine learning task, like classification or regression or time series forecasting, etc. And then within each algorithm, you're going to have a bunch of parameters, hyperparameters, that you, even if you are familiar with it as a data scientist, still you will need to iterate and do many tests. And okay, let's switch and tweak this hyperparameter. I might get better or worse performance with the model. And then you need to do this for many times, right? Like then maybe these different features, different algorithms, different hyperparameters for each algorithm, many combinations of parameters. This is a lot of combinations. You do it manually, and then until you get to the best model, it takes a lot of time, right? So this is precisely what AutoML tries to solve, right? But let me show you just a super quick demo, just to show you what I mean. It's a manual code. I have it in. So this is not AutoML, it's just a regular notebook in Python where you are, for this particular model of the car competition, you load the data set and data, and then this is kind of the code, which is just a few lines of code where you are saying you're going to use LigM, which is an algorithm, and then these hyperparameters. Okay, so it looks simple, looks just a few lines of code, but how would you know that you should use this algorithm instead of other library or like simple logistic regression or XGBoost, or there are quite a few algorithms, let's say around 10 for classification. And then within each algorithm, how would you know what values for these hyperparameters you need to use? Some of them might be clearer if you're familiar with this algorithm. Others you will need to iterate and do many combinations. So this is very time consuming, and this is what AutoML tries to solve, right? So let me continue. So what if we can simplify machine learning with AutoML, right? What is AutoML? So basically, AutoML automates all that process. Like you just provide the data, and then we do internally feature engineering, featureization of the data, so converting all the data to numbers, because at the end a model needs to have everything based on numbers, and then do the hyperparameter selection, and then to find the model, right? So basically, we do a lot of iterations, a lot of different trainings, creating different models, and then comparing all of those models until we reach to the best model. But as a user, you just provide the data, some parameters like timeout, what's my data, what's the target column to predict, very simple things. And then we do all this process about featureization, algorithm selection, hyperparameter tuning automatically. And then we generate this model leaderboard with, let's say, 10, 50, or hundreds of models, depending on how much you want to invest on finding the best model, until we provide, hey, this is the best model we've found after all the automatic iterations, right? So this is AutoML. I'm going to do a couple of quick demos about AutoML so you can see it. But also, before doing the demo, also a few more things about AutoML. It was initially like when we started like more than 2 years ago, based on the Microsoft research work. Then how AutoML knows, okay, I'm going to try this algorithm or this other algorithm, and then hyperparameter tuning. That's based on kind of a brain that we have in the cloud, based on the experience of millions of experiments with customers, right? And then what can you do with AutoML? Basically, these are the tasks supported. Initially, we have these 3 ML tasks targeting tabular data, so tables, in GA, like publicly available, right? And kind of in release. So classification, regression, and time series forecasting, right? That's what you can see it. But then since recently, we also have AutoML for images. So instead of targeting tabular data tables, you can also target models working with images. So for instance, you can do image classification multi-label, object detection, and image segmentation. This is in public preview, still not GA. And then we are working on another flavor specialized on NLP, so natural language processing for text classification, multi-label for text classification, and name entity recognition, this is going to be, well, it was yesterday announced, our private preview. So if you want to enroll to NLP, tell me also. So that's AutoML. I'm going to do a couple of demos about AutoML. You can use AutoML in the UI to get started, or if you want to have like all the possible configurations, then you can use also the SDK from Python, and that's today. And we're also working on next versions where you'll be able to define your experiments in YAML, and with the CLI you could trigger runs of AutoML, also from Python, and REST APIs as well. So let me show a couple of demos about AutoML. So this would be using the UI, which is the simplest way to get started. It's loading. Hopefully it's not going to be too slow on my machine. Yeah. So from Azure, your workspace, you can create a new automated ML run. And basically, the first thing that you need to select is your data set, right? So you can upload it first. I already have uploaded a few data sets here. So for instance, I could select this data set that I was talking about the safe driver. Okay, let's close this. Yeah. And then after you select the data set, you will have a few questions about how you want to run. I can select an existing experiment. I can just say demo. What's the target column? In this case, is the name is target. Could be a different like price or what I want to predict, right? The compute. So I'm going to use a compute cluster in order to train all the models, and then finally you select the experiment. Let's call it. Okay. And then here you select the task. In this case, it's a classification. I could see additional configuration settings like what's my primary metric to optimize for, or if I want to block some algorithms because I know that those are not good for me, etc. Right? These are kind of many more parameters, but simple to understand, like timeouts, exit criteria, when and so on, that you can also define in the SDK, but pretty simple to understand, right? And then finally, you can also specify what kind of validation you want to do in order to see what's the metric, the quality metric of your model. If you're going to do like a split the data for validation, or you're going to do cross-validation, and you can even provide a test data set for the last model, for the best model, with data that you never use when training, not even when validating, right? So this is all the options that we have, pretty easy to understand. And then you can do the same thing in a notebook or Python code. So for instance, this is the same data set. I'm not sure why the machine is going a little bit slow. And then when you finish here, then we will create a parent run of AutoML that will trigger many child runs, and each child run is going to be like a one model training. And then you could get like 10, 50, or hundreds of models, and then we compare that, right? So let me show you in here. So in a notebook, you use the Azure Machine Learning SDK in order to data in here, and in the data set from the workspace, but if it is not in there, so this is regular API from the SDK. I keep the data using a conversion to pandas data frame, describe the data. This is kind of regular and easy operations in a notebook. And finally, this is good with AutoML config class, right? You can see in here that with AutoML config class, which is this class. In here, I specify similar properties that I did in the UI, like the remote compute classification metric, the target column name, if I'm blocking models or not, plus additional settings. Like in this case, I want to do something quick, so just 10 iterations or 10 models instead of if I wanted assembling. So after models, kind of composing the best models into a single one and all that might be better, things like that, right? Of the experiment, and then it will do all the different models, right? So once you do this, you submit the experiment, and then we have a limit of 10 models, but you can see each model here, the different algorithms that it's trying, like GPM, XGBoost classifier, and so on. And that's what you see in the workspace. It's getting a bit slow, my machine. So in the meantime, let's see what's going on. Okay. So you can take note of this. GitHub.com AutoML-preview. This is the site where you can see the information about AutoML code gen. But I will talk about that now, right? But what to highlight is that when you, I won't show it in the slide until that is refreshed. When you get that list of models in AutoML, like the GA version can do now, basically you can just go, you can test it, you can see how it works, or you can deploy it as an endpoint, as a service, or you can even download the model, a pickle file, and then test it in a notebook or in Python, right? But it's just that you get the end product to deploy and to use, but you don't see how exact training, like if it's using let me try another browser. If it is using okay, let's continue because it's getting really slow. If it is using light GPM algorithm, that code you don't see it. Right? I will show it in a minute if it gets better. So basically, this is what I'm saying in here. The current state is that you can use it, but until now you wouldn't get the training code exactly how that model was built, right? Like if it's using scikit-learn or and etc. What you can get in the UI is, okay, that was the model name and the hyperparameters, but we're not getting exactly the training code. So that's why we are in a feature which is called AutoML model code generation. So the problem is that for many data scientists, they want to have full control of what they are deploying, like the model that they are deploying. Let's say, and that could be reasons. We have feedback from customers from data science that they simply don't want a black box model and then using it. They really want to be in control of it and control and see in it. They would like, once they get the model trained code, they would like to customize it, and maybe because they know that algorithm, and they would like to try a few tweak hyperparameters, right? Or we have other customers that simply because of regulations. For this week, I was talking with a data scientist from a electricity in California, and because of regulations, training code of the model that they were gonna deploy in production, right? And because then they might need to have like an audit for that model, or they need the for that particular model and the so that basically the problem is that many data scientists don't want to use a black box just to use the product that it creates. The solution is that we are feature to generate the code of any model that was trained by AutoML, right? So that will help these customers that they don't simply want to get the model and use it, transparency and even customization on top of that, right? So let's see if there's something slow in the machine. Okay, so the high-level design is this. Basically, you can select a list of models that we generate in AutoML, either from the UI or the SD. You can select any model, and then we will your shared drive space a couple of files. Just SDK code that you can run the generated code to train the model, and then the interesting code, which is a PY with the training code for that particular model, right? That's what I'm going to do in a few minutes. But basically, this PY file is going to you're going to be showing, seeing that it's using directly scikit-learn models, algorithms, or like GBM or AutoML or Prophet, depending on what kind of ML task you are using. And then we are also providing additional libraries for simplifying more complex code, especially when transforming the data. So this is a simplification of what we are doing. So basically, when you select any model, like in this light GBM in the UI, and click on the code, then you are forwarded to a code in the browser where you will see the PY code on with the algorithm and the hyperparameters. For instance, in this case, it's like GBM with these particular hyperparameters, and then you can see the scikit-learn pipeline with additional data transformations initially in this code, and then preprocessing, and then a model, and then you finally are calling for this particular model fit. So that would be train that model. But as a data scientist or developer, you can customize this code, these hyperparameters, and change the initial code before, and change the data that you are loading, etc. Let's see if this is going faster now. Not sure what's slowing down my machine. Okay, let me, I think I have, okay, here we are. So for instance, this is when you click on one model and on the button to see the code, this is the code that is generated. So in this case, we are doing a few functions here to split the data set that was created, then preparing the data, a few methods that is transforming the different columns, like imputing the columns if there are missing values, what you want to put in there, or doing the data transformations. So for instance, in this case, this is nice because all these columns are the same type and the data transformation is going to be the same. So we put it in a single list, and then we apply all the data transformations. And this is the method doing all the data pre-processing. And finally, this is the algorithm configuration. So you can see that in this case, it's a LightGBM classifier with this particular hyperparameter. So as a data scientist developer, you could either use this code and save it, register it for regulations purposes, or version this code related to the model that you are going to deploy, or you can also customize this code and tweak all these hyperparameters. And then here you have the pipeline, scikit-learn pipeline, internal pipeline with the 3 steps: featureization, pre-processing, and the configuration of the model. And finally, when you call fit, is when this particular model with this particular algorithm is going to be trained, right? And you would have that model trained by yourself. So at this point, this is your own code, and you can run this code whatever you want. As a convenient notebook, we are providing this particular notebook, which is not AutoML. It's just a notebook that helps you run easily this Python code to train a model in Azure Machine Learning. But you could also take that PY code and run it anywhere in your machine, because it's just using open source libraries and some libraries that we also provide, but are going to be decoupled, so you could run anywhere, right? But as a convenient notebook, we are providing this one, so it's just loading the information of your workspace, creating an environment with all the packages that code in the PY file is using, all the packages, Python packages for the training libraries and data transformations, and then using this class from Azure SDK, which is script run config. But this is just a way to run with the script run config to run that Python code, which is the code that we generated in a particular cluster in AML. So you will get it another model in the workspace, right? But this is not anything related to AutoML. This code is just a way to run easily this generated code in AML. But like mentioned, you could also run it anywhere. So that's the demo about code generation. Let me see if in here it's something is wrong with Chrome. Let's see if this is going faster. Okay, so you can see that if I go to an experiment in my work, just want to show you how or code. Well, looks like yeah. So I do experiments here, and experiments like a box or folder for multiple trainings. And So for instance, this is the one experiment. And then I will see here a list of pattern runs. So this is the one pattern run that, and if I click on models, so basically this has like the parameters that I did when training from AutoML, right? And if I click on models, you will see the list of the models that AutoML was trained, and one of them will be the best model, right? You can see like 10 models, and then in this case, this one was the best model. I'm going to choose this because ensembling is kind of a bit more complex about the parameters. This is ensembling multiple algorithms, so I'm going to select any of these. So you can select any model that's trained with AutoML in order to see the training code that we generated. So this is a particular model, right? Once you select a model, like I was saying, you can deploy it, you can download the pickle file, you can use it, but this is what's new, this view generated code, right? You could also see the hyperparameters in the UI and the data transformation that was done. It's going to be refreshing. So, but the important point is that if you get here just the hyperparameters, you would need to still develop your own code, right? So because you can see here, okay, the training algorithm was like GPM, and in this case, you buy the code parameters. But all the process, if you want to kind of do this model without code generation time, you could take a look to the hyperparameters, but then the rest, like the automatic featureization that we do with the data, you wouldn't have that. So that's why when you click to view generated code, then it's copying and moving to these notebooks that I was showing here, the book and the QY. What's the process down there? Okay. So let's see if there's any question. Yeah, we'll put a link to the slides. Okay, so let's continue.
Cesar, maybe you can post it now, because some of the slides are very pixelated. I think that's the issue.
Can you see it now?
Sorry?
You see the slide or not?
Yes. So they are visible, but sometimes, especially when the text is smaller, it's not blurry but pixelated.
Mm-hmm.
I think that's what Adrian meant.
Maybe. Okay. So the value propositions of code generation basically are these three. The most important thing is it's helping data science productivity, because if you use AutoML as a way to find out what's the best algorithm and hyperparameter, you still want to have the training code, and you would need to invest a lot of time on do that reverse engineering from all your data transformations and all the code, right? So if we already provide the training code, then you scientists can just take it and customize it it and train with it. So it's going to be helping a lot, right? So it's like two levels of productivity. One is AutoML itself, because we do many iterations searching for the best model. But then if you want to have your own code training the model that you're going to deploy to production, then we generate that code, and you can even, once you have code, then it's also MLOps ready, because you can put that code in your MLOps or DevOps continuous integration and continuous deployment of your models, and have like a deterministic reproducibility of what you are deploying with that code, right? You can get new data, train a model with the same code, and produce a new model, which is going to be very deterministic because it's using the same algorithm and the same hyperparameters. Right? And finally, if you also want to even tune further that particular model with those hyperparameters, there's another technology in Azure Machine Learning, which is called hyperparameter tuning, where you can provide an algorithm and tune only those hyperparameters for that particular algorithm. So that's another possibility that you can also do. Right. So there are a few more topics that I can talk about AutoML, but first of all, I wanted to do this call to action. So you can enroll to the private preview of code generation. So if you need to register to this form, and what's important is send me an email providing your Azure subscription ID. So we will enable your UI, so you can see that button to go to the generated code, because otherwise you won't see it, right? So you need to have your subscription ID enabled for this private preview in order to have the end-to-end experience. But in any case, I mean, it's private preview just because it's not supported the same way, because we are still developing it, improving it. So it's not supported like if it is GA, right? But you can go to this private preview GitHub site, and it's public from the sense that anyone can enter into this GitHub site. You can see how to get started, kind of an explanation of the code that I was showing, and the UI. You can read about it on how to use it, because it's not private because you cannot know about it. It's just private preview because it's not like a GA when it's supported publicly, right? But you can get into the GitHub site and see information about that. And then if you want to try it in the UI as well, and then send me an email with your subscription IDs. Any question about code generation in AutoML? Before I also want to mention a few other topics about AutoML. Okay. So other areas that, oh, there's a question now. Let's, so the question is AutoML restricted on the search limit when trying to find the best parameters? I guess the complexity can be high on more than 3 parameters. Not sure I'm understanding the question. The hyperparameters per model, it's an open list. So some models can have, or some algorithms can have 3, 4, 10. So the number of the hyperparameters is open, right? So there's no restriction about that. And then AutoML will be doing hyperparameter tuning per algorithm and trying different combinations based on the history that we have from many trainings from customers. And then all these combinations of algorithms and hyperparameters are used. Each combination is one model training that it's shown in the model list, model leaderboard list, right? But there's no limit on the or limitation on the hyperparameters per algorithm, if that was the question. And then about the search, if there's any limit about that, it is not. There is not. Like you can, if you want, you can put like a let's say infinite search for best models. So instead of training like for a few hours and then let's say tens of models, you could be training for days, and then you could have like hundreds or then thousands of different models. But that might be in some cases a waste of time and resources. So what we also have is a property that it's early exit or early termination, which means that, let's say, we've been training and we multiple models, we might have, I don't know, like 40 models or whatever. And when we detect that when the next model that we are training for for some time is not improving almost anything, like very, very little for quite some time since we found a best model, then we say, okay, because you said you want to enable early termination, then we stop. So it's a way to stop when clearly it is not improving when training more and more models. Then it stops and exits and say, okay, this is the best model I found, right? But if you want, you could be training and training and training more models without limit as well. Okay, so other things that we are working on for AutoML, this is a new feature, and is AutoML for images. So initially, like I mentioned, AutoML in Azure was supporting just 3 ML tasks: classification, regression, and time series forecasting for tabular data, for tables, right? But now we are also targeting images. So what's called also computer vision, right? And this is in public preview. So you can today go to the docs, because it's in public preview, and search for AutoML for images, and you will see the different ML tasks that we support for images. So you can classify images, like this is a cat, this is a dog, or you can do also object detection. So within the same picture, you can detect different objects, different images, or you can do also instance segmentation. And then something that I want to highlight is if you know Azure and Azure AI, you might also be aware that Microsoft also has Azure Cognitive Services, right? And in Azure Cognitive Services, you have Azure Cognitive Services, Computer Vision, and Custom Vision, right? So from a high-level point of view, you could say, why are you doing this? Because it's kind of similar to Custom Vision in Cognitive Services, right? So even when from a high-level point of view looks similar, it's a different level. In Cognitive Services, it is a black box completely, because you just provide the images and what you want to do. If I want to do image classification or object detection, and then it will train a model, and you can just deploy it and use it, right? But with AutoML for images, you are able, when you define the AutoML experiment in code, so it's not just UI, it's also in code, you can specify, even if you want to try a particular DNN, so neural network architecture. So for instance, if you want to use like Inception V3, or for object detection, YOLO, or like you can choose DNNs architectures, plus you can also specify ranges of hyperparameters of those DNNs, of those neural networks. So the level of customization and definition is lower. So this technology, AutoML for images, is targeting more data scientists. Cognitive Services is more for application developers who just want to create a model as a black box, right? So Although we still don't have, and that will take more time because it's in public preview, we still don't have kind of for a particular model code generation from images. That is still TBD. But you are able to specify the as parameters in AutoML. Like I was saying, like I want to try with different combinations within these ranges of hyperparameters, or I want to focus on this particular DNN, or all these. Like you have a what you see in there, like tunable hyperparameters, right? Then another area that we are focusing on is AutoML for NLP, DNN NLP. So even when in the regular AutoML classification, you can also have columns that are text, and it'll work. And we also use DNN like BERT for doing all the featureization of that text into and convert that to numbers. So it works as a classification problem. But we are creating these specialized ML tasks for text. So for text classification, the quality of the model will be even better. But then we are adding new ML tasks for text that we didn't have previously, like multi-label classification, right? So multi-class classification means that you can assign or predict that this text is something, but just one possibility. That's multi-class classification. Like, for instance, a great example is sentiment analysis. You can say if, hey, this text, based on analyzing this text, the sentiment is positive or the sentiment is negative, or could be multiple different classes, but just one, right? You can just assign or predict one of those classes. But then multi-label classification goes further, and you could assign different classes to the same prediction. So a good example is, for instance, if you have a product and you want to predict what departments or areas in my e-commerce I should assign this product, because maybe it's not just one area. This product could be assigned to multiple areas in my e-commerce, for instance. So that's multi-label classification, which is something that we don't have in the regular classification, and it's implemented here. Or you can also identify entities, like names, entities within the text, right? So this is something we have in private preview since this week. So if you are also interested on AutoML for NLP, like specialized on natural language processing, send me an email and I will put you in contact with the program manager who's driving NLP. Okay. And another feature that we added that I'm also driving is adding the capability for using test data sets in AutoML experiments. So previously, you could provide in the experiment, like what's your training data and what's your validation data, and then get metrics with that validation data. So for each model that we create, we are testing with that validation data that is not used for training, right? And then those are the metrics, and based on that, based on those validation metrics, you get what's the best model, or the second, the third, and so on, right? But in data science, what happens is, since we are validating again and again with the same validation data, even if we do cross-validation, there's some bias, because we train a model, we validate with that data that was not used for training, and okay, we get, let's say, accuracy 80%. Let's try this other model, this other algorithm with the same validation data, and so on. At the end, because we are validating again and again with the same validation data, the best model that we reach to, it has some bias because of using that validation data for getting the metric. So that's why in data science, once you get your best model, you usually want to test it with an additional test data that was never used, not even for validation. and get the test metrics for that best model, right? So this test data will be only used for the best model at the end of the end-to-end experiment. So if you get 10 or 50 models, then you will we will get test metrics for the best one. Although we also having another possibility, which is, okay, I just want to go to any model that was trained with AutoML and get test metrics with this new data that I got 2 weeks later. And you can do it in the UI or in code as well. Selecting a particular model from the past and providing test data, you get test metrics for that particular new data. Okay, so this feature is also in preview, but it's public preview, so you are able to test it today. We have a few documents public about this, about the test data set as well, so you can use it. So some other resources, these are just regular resources and contacts from our team, and about AutoML end-to-end tutorials and our team, my team alias. So my team is the training intelligence team in Azure Machine Learning. So AutoML, but also other areas about training. So with that, I think I'm pretty much done. Here you have my contact. You can send me an email to cesardl@microsoft.com for any further question. And most of all, if you're interested on enrolling the private preview of AutoML model code generation, please send me an email, send me your Azure subscription IDs, so we will enable that subscription so you can see it and use it. Okay, we are very much, this is a perfect moment to get feedback because it's in private preview. So if you start using it and you would like to have something working in a different way, or hey, this is a pain point for me, or I'd love to have this in the generated code, right now is the perfect moment to say it, because there are a lot of chances that we'll be able to do it before the public preview. But once it's in public preview and then released, then changes are harder, right? So public preview will be coming early next year, but during December and January, it's a perfect time to start using it, see if you like it or not, or if you like this area or a different code or the way we are doing it, any change that you would like to have. If you have a magic wand, I like this change in the code generation, tell me, and we can evaluate it. And usually we are very much customer driven, so we prioritize all the feedback that is coming from customers. Okay, so with that, if there's an additional question, please go for it.
Thank you, Cesar. I actually had one. I was wondering, does the code generation feature apply only to tabular automated ML, or also to the other features such as the NLP or the images?
Yeah, great question. So today it's only targeting the tabular ML tasks, so classification, regression, and time series forecasting. In the future, because it's in development, it's in private preview. In the future, we will probably expand it to the other ML tasks. But the other ML tasks, the images and NLP, are precisely also in preview. So it's kind of too early for us to do also code generation of something that is still not finished, right? So that's why.
Yeah, totally makes sense. Totally makes sense. I was also wondering if we're talking, would you recommend running? So when running AutoML, would you recommend just running it once at the beginning of a project, maybe to get a baseline, or running it repeatedly over the lifetime of a project to get to update your models and make sure they're up to speed? Or what strategy would you recommend in this scenario?
Yeah, that's a great question. It depends on the customer and the data most of all. But I'd say that it's good not to just use AutoML once and then forget about it and focus on that particular algorithm, because then you might be losing maybe better approaches in the future, right? So it depends on the data, because sometimes with a particular data set type, maybe even if you have new data, maybe the algorithm, the best algorithm is going to be the same. But in other cases, maybe you retrain and do all the different trainings, and maybe the best algorithm is going to change. Also the hyperparameters, of course, right? So I think that is a good strategy to initially do quite a few kind of side trainings with AutoML to confirm that, hey, the algorithm that we are using with my code is the right one. So maybe once a week, or more than time in reality is depending on if data changes. So if you have a lot of changes on data, then maybe every time that you get a new data set, new data, it would be good to test it also with AutoML, just to make sure that your algorithm and the hyperparameters that you have are kind of on par with another best model that might be found, right? But the point is that in many cases, customers want predictability. Like if they get new data and that algorithm was kind of explained and analyzed, and they know what it's doing, they want predictability and make sure that it's working, even if you retrain and you deploy again, right? Because you'll never know. Like sometimes, like if you were deploying automatically with a new algorithm, then that would be in different libraries. And then what if it needs, I don't know, it's slower or needs more memory? Like the moment that you change the algorithm, the libraries can change and the deployment can change. So that's kind of the predictability that many customers want for production. So a way to make sure that this is what we are doing and deploying, and this is the training code. That's why some customers prefer to kind of have a more secure approach with the training code, right? And also full control. It's also a matter of, if you're a data scientist that you have a lot of skills on like GPM and particular algorithms, and you want also to customize it, you can do it. You can have transparency on what's done. You have flexibility on using AutoML or using a lower level as you need, right? So, but related to your question, yeah, we recommend that don't use AutoML just once and forget, because you might be losing better choices in the future. Maybe you might need some time, but then if the data changes, if you start adding additional features, additional columns in the future, that can impact on the algorithm. If the data is very similar, but just new data, maybe chances are that the same algorithm is going to work the same way. Yeah, but that's a great question.
No, so it totally makes sense. So basically, yeah, we should run AutoML repeatedly. We should keep in mind that, yeah, we can retrain the AutoML generated model every now and then. But also, if we want to, if maybe the distribution of the data changes over time, then it might be worth to invest in another round of running AutoML to maybe find a better model or better weights for the current model. So thank you.
Yeah, that's the recommendation.
All right. Well, I must say, not sure if Dan has other questions.
No, I'm good. I actually enjoyed, let's say, the conversation between you guys, and maybe that's a subject for a different talk. We could do something or a panel on this subject, because yeah, AutoML is getting more and more interesting and more mature as a technology. But that being said, Cesar, we loved having you here, and hope to see you next time.
Yeah, thanks a lot. Thank you for your time, guys.